Hello everyone. In the previous video, I explained you how to uh, draw the main and the most important sketch for designing bevel gears, which defines the relation between the pitch diameters of pinion and gear, also the tooth profile, in fact, the relation between the cones of pinion and gear. Okay, now in this video, I'm going to explain you how to model the teeth and so that our pinion and gear will have a more realistic shape. Okay, first we start with pinion and define the profile for the teeth. To do that, I first need to define a reference plane which is perpendicular to this cone. Okay, I use a reference plane which is also perpendicular to the pitch center line. I define this line and this surface so that a plane appears which is blue, which means that is completely defined. Here you can see fully defined. Okay, uh, I click OK. Now uh, on this plane I should draw the profile of the teeth. Okay, so I click on the plane here and then I open and sketch on it so that I need to get normal on this plane, so I push the space button and click the normal tool. Okay, first I draw a horizontal line which crosses the bottom of the point here. Let me show you. Okay, just I draw a horizontal line, but this line, let me turn a little, but this line must be coincident with this point. So I select this point, control this line, and then midpoint, because this is the midpoint of my line. Okay. The best method to define the involute curve, which defines the profile of gears, profile of the teeth, I can use the spline command. The spline command, I use the spline command, select here, put a point here and another point here. Okay, it's good. Then I define a center line here so that I can mirror my spline like this. Okay, I use a mirror command to mirror this spline with respect to the center line I just draw. Okay, and then I close the contour by a horizontal line. Now I should put some dimensions to this sketch so that the profile of my teeth are more realistic. Uh, this part is a little try and error so that you can get the best profile, but uh, this line is about, in fact, this dimension must be a little bigger than the module of the gears. For example, I put 3.5. Remember, our module was 3. Also, I add another relation between these 3 points, a horizontal relation. This distance between this point and this point is somehow the half of the circular pitch. So I define this distance to be somehow it must be 1.5 multiplied by your module. So I put 1.5 and our module is 3. So I define this dimension to be 4.5, but maybe later you should change these dimensions so that you can get more realistic profiles. Okay, and also Let me get normal again. You can change somehow your dimensions. It's better to define this dimension also. It's this dimensions is somehow 2.5 multiplied by our module, which is 3, as you can see. Okay, as you can see, it's almost tangent to the top of the sketch. To avoid any difficulties, I add another more. For example, I add 2.6 multiplied by 3 so that I will make sure that this line always will be out of my model. Okay, now I want to use the sweep command to model the teeth, so I need a pass. In fact, I made a profile and now I need a pass. Okay, I exit this sketch. My path will be drawn on the main front plane. So I open an sketch on the front plane. My path uh, is this line, as you can see from the middle of the sketch and in the bottom center line of the teeth. Somehow like this, and this must be out of my model so that I add a dimension to this. For example, I add 25 so that I will make sure that it gets out of my model. Okay, we are done. Now I want to use the sweep command here. So the sketch tree is my path and the profile is in fact this sketch. As you can see, a preview is shown, which is seems to be good. And then I oh sorry, I use the sweep command. I should use the sweep cut command. So I select sweep cut command. Then here I can use from the design tree my profile and then the path. And as you can see, a preview is shown, and when I click, you can see that my teeth profile for one teeth is made. Okay, to make things better, I use the fillet command to fillet these four lines. Oh, it's on the variable radius fillet. I use a fixed radius fillet. A fillet should not be very big. I use, for example, zero point 0.5. I use, in fact, I select all these four lines which define the root and top of my teeth. Okay, and the first teeth is made. Now I should circular pattern these features to get all my teeth. As you can remember, I told you that the speed ratio is 2 and the number of pinion teeth is 20 and the number of teeth for gear is 40. So I use the circular pattern command from here. The direction is here and the number of teeth is 20 and the features that I want to in fact pattern are cut sweep and the fillet. Be careful to select appropriate features here. Okay, and here the feature scope, which means that what bodies are affected by this feature. It's usually on the auto select, but to be more precise, I clear this click and then here I select this body, which means that the feature is only applied to my pinion. And then I click OK. Wow, very beautiful. As you can see, the teeth of my pinion is made. Okay, now I can do the same for the gear and the gear will have 40 teeth. To do that, first, as before, I need to define a reference plane. So from the reference geometry, I select plane. I select this line. Be careful to select the appropriate entities for defining your plane. I select the center line which in fact crosses this point, which defines the pitch diameter, this line, and then I select this surface so that it will be perpendicular to the center line. Okay, now I select this plane and open and sketch on it. Then I make normal to this sketch. Again, I draw a horizontal line and then I rotate my sketch so that I can see better. I select this point, hold control and then this point and add a midpoint relation. Okay. And again, I get normal to my sketch. I define the distance, in fact, the distance to be equal to 3.5. As I said, it's almost equal or a little bigger than our module, which our module was 3. Okay, again, I use the spline command to design the profile of my teeth. I use 2 points for my spline. Then I will add more dimensions. Then I use a center line to define a vertical line which I want to use for mirror command. Okay, then I select the mirror command to mirror my spline with respect to the vertical center line, and then I close my, oh sorry, I close my profile, my sketch with a horizontal line. Okay, now again, as you can remember, I put this point on my sketch to define the pitch diameter. Now I add a relation between these 3 points to be horizontal. Good. I again get normal to get things a little better. And now I should define this distance, which as before, for example, I can use 1.5 multiplied by a module which was 3. Okay, you can have more control on your profile later by defining more dimensions. But here I want to just show not perfect, but approximately the profile of the tooth, which is the involute profile. Okay, I also add a relation here. For example, I add a little smaller, for example, 7.2. Okay, good. The profile, as you can see, is approximately similar to an involute profile. Okay, now I exit my sketch. Again, I should define my path. So I open and sketch on the front plane and draw this line from this point. Be careful from this point. I draw a line which is collinear with the bottom center line of my teeth, and I add a dimension here so that I will make sure it will also exit my in fact model, so that the teeth will be cut completely. Okay, I exit this sketch. Now again I use the sweep cut command. Here I define the profile. You can select the sketch from in fact the model, or you can use the design tree. The design tree is more better because it is more exact. Okay, I use my profile which is here, and the path which is the sketch just I drawn, and you can see a preview of the teeth of the gear. Okay, now here I have the teeth of gear. Also I add some fillets here. I select these four edges for my fillet feature, this line and this line, and the value of zero point 0.5 seems to be good for this. Okay, now I modeled one piece of the gear and I should also pattern it. So I use again the circular pattern. For direction, I select this line. And here now, the number of teeth is 40. Remember, the pinion has 20 teeth and the gear has 40 teeth. Okay. And here also I select my features, the cut sweep and the fillet command, so that the teeth is modeled completely. And again, I clear this click. And for the feature scope, as I told you, means what bodies are affected by the feature, which is the circular pattern. And I select my gear and then I click OK. Wow. Now, as you can see, the gear is also complete and exactly the number of teeth are right. So we have 20 teeth on the pinion and 40 teeth on the gear. Okay, thank you. And in the next video, I will explain you how you can import this pinion and gear in the assembly so that you can see the relation and how by revolving one pinion, the gear will also revolve. And also I will make some simulations to see the gears in action. Thank you for your watching.